If we are using a sample to approximate the unknown value of a population parameter, let's kind of think about a couple of issues that might come up in that process. For me, in the previous slide, I picked a sample of 30 words, not randomly, just 30 words that I liked, and I got a mean of 4.3 and a sample standard deviation of 1.74 letters. And let's say some other organization which is using their own estimate for this same population parameter, they collect their own sample of 30 words. So question A is saying true or false that the value for the X bars are going to be different for different random samples. And in general, this is certainly a true statement. So it would be unlikely that this second organization would pick the same sample, the same exact sample of words. So even if they have one word different than my sample, our means are going to be different. So these values are going to change. These sample means that we're using to estimate the population parameter are going to be different for different samples. The next part B is saying true or false the value of mu, which is the population mean, will be different for different random samples. And that is a false statement there. The population mean is what it is, right? So we have all of these words in Raspberry Beret, and if we had access to all of that data, we could calculate what the actual mean letter length of all words in Raspberry Beret are. And that would be the same regardless of my sample of 30 words or the sample of 30 words that another organization picks. So the point here is that the bullseye, which is the population parameter, that's a fixed target. And what is varying is the sample that we pick to estimate that target. Okay. In part C, it's asking us to prove that the probability of X bar going 1.96 standard errors below my sample mean to X bar going plus 1.96 standard deviations above my sample mean, that the probability that mu falls between those two values is 0.95. So if we want to prove this statement, we can do this algebraically. So for example, the first thing I can do is subtract X bar from here, here, and here. So if I subtract X bar from everything, we're not going to change the inequality, the relation in the inequality. We're just going to change where that inequality is centered. So I could, first of all, subtract X bar from the first term, which would give me this. I subtract it from the middle term, which was mu, and then I subtract it from the upper limit, which was that. Okay, and so keep in mind that this value over here, that's measuring the spread in the sampling distribution for the mean. So that's the standard error. So just by subtracting X bar from everything, we've just kind of shifted the inequality here. And now the next thing that we can do is divide everything by the standard error. So that would give me 1.96 over here. And now in the middle, we've got mu minus X bar over sigma X bar. And over here, I have a positive 9.6. So by subtracting X bar and then dividing by sigma X bar, we've got this equivalent inequality, and this over here is actually the z-score of X bar. So if I replace that middle with z to represent, that's just the z-score for any value taken from that sampling distribution, then we've got this. And you can check that for the standard normal distribution, that is indeed equal to 0.95. So what does all of this tell us? That's what part D is asking us to interpret what this interval means. So if I pick a sample, and from that sample I calculate a mean, and that mean is given by x bar. Then if I go 1.96 times the standard error of the sampling distribution, either above my mean or below my mean, so by adding and subtracting that to that mean value, I get an interval now of values. And what we can see from this probability is that interval of values, it has a 95% chance of successfully containing the value of mu, which is the parameter we were trying to estimate. Okay, so what I can see again, just to say that again, is by going 1.96 times the standard error above and below the mean that I calculate from my sample and constructing an interval in that way, that interval is going to capture the population mean 95% of the time.